Hello everyone and welcome back. Today we will continue talking about the database instance, but we will start talking about the System Global Area, the SGA. I know that we have a lot of theory information, but this is very important in order to pass the exam and also in order to understand the practical. Okay, so what we will learn in this lecture? We will understand the System Global Area, the main tasks of SGA, the shared pool, the database buffer cache, and also the redo log buffer. So we will understand the three parts of the SGA today. As I told you, that the Oracle instance is a set of memory structures and processes. Okay, in the previous lecture, we talked about the PGA and the server process. In this lecture, we have to understand what is the System Global Area. Actually, the SGA is a group of shared memory structures that contains data and control information for one database instance. So it contains subcomponents. Each component has a specific task. So the main task of SGA, maintaining internal database structures that many processes access concurrently, caching data blocks, read from disk, buffering redo data before writing it to the online redo log files, storing SQL execution plans. Maybe you will tell me, man, I didn't understand anything from this. Don't worry, we will understand everything in details. So when we go deep one by one, you will understand what is the main task of SGA. Just focus with me, okay? Very nice. Now, let's start by the first part of the SGA, which is the shared pool. The shared pool is the most important component of SGA. Actually, the main purpose of the shared pool is cache non-user data like data dictionary. So it cache the data dictionary. What is the meaning of data dictionary? It is metadata. What is the meaning of metadata? It is data about data. For example, DBA underscore tables. So when the user doing select statement, Oracle have a lot of job to do. He need to know if this table exists or no. From where he know? He will know from the data dictionary. So it's better to cache the data dictionary into a part in the System Global Area called shared pool. So the data will be faster. That's it. Okay, we caching the data dictionary into the shared pool for performance. That's it. Okay. The shared pool contains subcomponent. So it contains also subcomponent like data dictionary cache, library cache, server result cache, and many others. No need to go deep more about this. Okay, very nice. Now, another task for the shared pool, store the cached information about each SQL statement that is executed, like the execution plan. What is the meaning of execution plan? Actually, it is information about the SQL statement, and it's like the best way for executing this select statement. I will give you example. For example, I have a user A, user session. He is doing select star from depth, for example. So Oracle will make execution plan information about this select statement. This means the best way to execute this select statement. So Oracle will store the execution plan information to the shared pool, and you can see it here, parsed SQL. So the first time the user make this select statement, we call it hard parse. So Oracle has a lot of things to do. Okay, but now if I have another user want to execute the same select statement, So Oracle will read this information directly from the shared pool and no need to regenerate the execution plan again. And we call this is a soft parse. Now let's talk about the database buffer cache. And this is the second component of the system global area. Actually, it is responsible for caching database user data. So this is the difference between shared pool and database buffer cache. So it caches the data for the user. Okay. The buffer cache caches frequently accessed database data into memory, and this is lead to more performance. Note, the buffer cache caches a block of data instead of individual rows. And this is very important, and we will understand what is the meaning of data blocks, because this is the smallest unit for the storage in Oracle database. Each block equal 8 kilobyte by default, and we can change this value, and we will talk about this later. All users who are connecting to the database share and access a single database buffer cache. Remember this, and that's why we call it System Global Area, SGA. So it is a shared memory for all users. The buffer cache, including the key pool, recycle pool, and many others, and no need to go deep about these subcomponents. Now we will talk about the redo log buffer. So you can see this part, we call it redo log buffer. Now, actually, it is a circular buffer that holds information about changes made to the database. So it only contains the changes made to the database. Okay, designed to store redo entries. So this is the main purpose of the redo log buffer. What is the meaning of redo entries? Actually, redo entries is a small records that reflect any changes made to the database as a part of transactions or database structure changes, which is mean DML or DDL. Okay. Note, redo entries are used for database recovery when and if needed. A very important note, the redo log entries in the redo log buffer are also written on a periodic basis to a set of files in our database storage known as a redo logs files. We will understand this later. So remember that also the redo log files related to the redo log buffer. Now I will give you one example. For example, I have a user session and this user making update statement. So the changes are applied to the actual rows which are cached in the buffer cache. So this update statement will be also in the database buffer cache, which we take it in the previous slide. But also Oracle will generate a redo record and store it in this area, which is the redo log buffer, which contain only the changes. So when the user make a commit, so these changes will be written to the database direct. So, but I don't understand, man. Why not to take these changes directly from the database buffer cache? So why Oracle do the changes in the database buffer cache and also write these changes in the redo log buffer? Because this area only for the changes. So writing the changes from the redo log buffer, it will be more faster because the database buffer cache containing a huge of informations and it is more secure to take it only from the redo log buffer. So it is for the performance. So taking the changes direct from the redo log buffer, it will be faster than reading it from the database buffer cache because it contains many information and it will be very busy. So that's it. So this information for today. Thank you for listening and see you in the next lecture.